Good afternoon, one and all. On behalf of Computer Engineering Department and IEEE Student Branch of KVTCOE, I would like to welcome our today's guest, Dr. Bennare ma'am, and all the participants for this session on the 5th day of 1 week faculty development program on research and emerging trends in digital forensics. It's my pleasure to introduce Dr. Bennare ma'am. Ma'am is Head of Computer Engineering Department from SIES Graduate School of Technology, Mumbai. She has completed her ME in Computer Engineering from Mumbai University and research work under the guidance of Dr. Satish Devne in the domain of digital signature and security. She has around 19 years of teaching experience and her domain of work is majorly cryptography and system security. She has published nearly 10 papers in various conferences and journals. She is instrumental in organizing various events aiming towards shaping the career of young minds. We are fortunate to have Madam as our resource person for the session. I request Dr. D.V. Medne sir to felicitate Dr. Bennare ma'am. Thank you. Now, I would like to request Dr. Bennare ma'am to start with her session.
Good morning all. I'm very much happy and fortunate to have this set of young minds in front of me listening for some sort of work which has been carried out in the domain of security. So I have been given with the topic of how digital signatures could be used in forensic environment. So what I did is I thought of giving you some sort of insights into what are areas of usability, applications and the concept behind signatures and proxy signatures. So most of you, at least during our curriculum and teaching the contents, we have been through using signatures. We are well accustomed with what the digital signatures are providing and how they are useful and so on. So my focus will be on some sort of alternatives, or we can call it as some sort of derivatives which are existing as a part of authentication and authorization operation in the digital signature environment. So when we discuss or when we do look into digital signature standards, what is our major focus, even if we are looking at it from some sort of, what should I say, a research point of view, or when we are looking at or trying to understand the concept of digital signatures, we are majorly focused on what sort of security aspects are provided by it, right? So we look at it as providing confidentiality or integrity or non-repudiation, and how that is achieved through different signature standards. Now, how exactly or how actually in reality digital signatures are used by a number of different users or professionals, and what sort of difficulties they do face when they are using digital signatures in a day-to-day life. So most of our documents that we receive, or majorly when I researched in this particular domain, we found out that the e-governance transformation was the thing going on. Now we can say that the e-governance has majorly been implemented. It is in a phase of taking advancement and all. But therein, the digital signatures were majorly being used for providing the authentication and authorization. And what we understood when we are going through the various mechanisms that the e-governance system has implemented, from as simple as being providing that this is the authenticated person who is being given with the rights of signing the documents, or what you can call it as accepting, validating the documents. So that has been taken care by, or that part has been taken care by the digital signatures. So when these digital signatures are issued, they are majorly being issued, or still today they are being issued in the name of an individual. So if I am a professional, I am a CA and I am issued with a digital signature by a certifying authority, it is majorly related to the IDs which I am providing to them. So there is something called as digital signature certificates, or X.509 as a standard which is used, and which provides these details of authentication, and which are then verified as and when the signatures are produced. So what lies if the signing authority is not there? So many of you must have given in your professional career that I am giving a charge to someone else when I am on leave, or I may not be able to present there physically, so and so person can be a charge. So that is what the actual real life, you can assume it as the condition for the delegation of the authority. So if I am authorized to do something, say I am authorized to be as a head of the department, and so I am authorized to do some XYZ things. So what if I am not there, someone else is taking my charge. So that concept, if I want to implement it in a signature environment, how it could be possible. So that has given rise to a concept of delegating the power to the users, might be subordinate, might be to the colleagues, or to someone you are designating. And that delegation has lot of things associated with it. Now you can visualize that when I am delegating my power as a teacher to someone else, so I have some set of conducts that are associated as a teacher. When I am delegating my powers as the subject coordinator or a course coordinator or something, I have some set of again task list, and for which I am assumed to be responsible for, and so on. So I am assuming that most of the attendees are teachers and they may be able to relate it. In real life, this might not be the case. So when you are dealing with e-governance as such, it is these set of areas or departments for which some particular person is designated or held responsible. He is given with some set of tasks which are under him, and might be he is required to delegate that to someone else. So someone else could be either his colleague, superior, or some subordinate working under him. So that delegation has got, you can say, a number of different aspects or things which are to be looked into, and that is what exactly the proxy signatures are doing. So my talk is more concentrated on where exactly proxy signatures are used and how the proxy signatures could be utilized. Most of the cases we can say that they are being used in the forensic operation. So towards the end of the talk, I will be going through the forensic implementation, or what are different aspects which are related to the forensic implementation of it. So how many of you have actually seen the documents which are digitally signed, or you could relate it? Few answers. any document which you go through in your day-to-day life, which birth certificate, Aadhaar card. Okay. So the certificates or the documents which are issued through the government, how do you differentiate that this is a digitally signed document or so? How you? So you have some mudra or something enlisted on it, and you try to relate it that this particular is digitally signed document. What if you reproduce it to someone else? How do they identify this is a validated document? ID is present or some sort of scanning which will relate to. So what we call it as some sort of validation is required. So there can be someone who is signing, may not be physically signing it, he is being issued with digital signature, and the authorities are signing on those documents, and you have some set of validating algorithms or validating proofs for finding out that it works or this is the same. Now, how do you relate it to the cryptography when you are looking into the digital signing operation? Anyone able to recollect? I am not expecting that everyone is from cryptography domain, but yes, so many of us have gone through public key infrastructure. Few of us may be able to relate it directly to the RSA algorithm or any other algorithm which is in the public key domain. So usually when in real life the digital signatures are issued, there are certain numbers or say serial numbers which are issued, for which behind the cryptographic algorithms do work. So there are certain cryptographic algorithms, and the more efficient the algorithm, the more you can say secure signatures are getting generated, and there are whole lot of standards associated with it. So what lies behind, if I am trying to relate some sort of security algorithms or some sort of signature security algorithms to the cryptographic algorithm. So many of you may be able to recollect that when I am talking about a public key and a private key which is used in RSA algorithm. So for a given public key, there has to have a multiplicative inverse, and that could be only one for a specific private key. So those who are in the security domain may be able to relate it. Those who are not in, they can just recollect that usually there is one element for which there exists a multiplicative inverse, and any one of them you can call it as a public key, another one you can call it as a private key. So the mathematics is not letting that one particular public key to have multiple private keys or vice versa. So you have to have for that element only one multiplicative inverse existing, and with that it makes it secure. Your entire security or your entire signature algorithm makes it secure because for any specific public key you have only one specified associated private key. So this entire concept of having one public key, a corresponding one private key is being demolished if you are referring to a proxy key. So what is proxy signature? That I am giving someone authority to sign on behalf of me. So that is what a proxy signature is being referred as. But how does that works in a digital platform? Or to be rather not looking into how that aspect of signature generation or signature verification comes, but rather my focus will be on how that mathematics or cryptography of that works in the background. So few of my contents of the talk will also be related to what that is. It permits that you are able to generate multiple private keys or the part of multiple private keys which could be related to one specific public key. Hope everyone is able to relate the talk. So at any point if you find out that it is not being accepted or being understood clearly, you can raise your questions. So these are the things, few of the elements like why do we require authority delegation. So as I gave you example that I wish to be on a leave and someone should be there in place of me. who is going to take care of the tasks which are given to me. So on a digital platform, someone should take care that if there are 100 applications for income certificate, then they should be processed, they should be signed and should be submitted and so on. So that is what the signatures are majorly being used for the purpose of that the signing authority has the rights and it has been checked, the contents are being checked, the document has been verified and so on. So whole lot of proof is or that is responsible or whole lot of proofs are available with that only one signature. Right? So if you could see with the changing trends, we could see that the demand of the digital signatures has raised quite in an exponential manner when we are moving more into the digital era, like my small payment wallets and other things. So they have also had some sort of security algorithms, though not directly related to the signature algorithms but working on a similar manner. So there are few applications wherein you may require to pass on or delegate your authority, and these applications, as I mentioned, in the e-governance system, those applications are more, or those you can call it as the implementation aspect or usage aspect point of view. When you are more moving into the e-governance complete digitization, you need to have someone who, or the systems in the background, maybe servers or set of servers, who will be processing and generating, verifying, validating and signing the documents in an autonomous manner. So they are all being considered as the probable candidates wherein some authority is required to provide the delegation for it. So you can consider it as we will be progressing ahead. So there are few aspects still in the e-governance scenario which requires manual intervention, wherein the manual or the manpower is required to further process it, proceed ahead with the applications which the citizens are making. So if we look at an entire scenario and talk of or think of optimizing it, the more amount of authentication and authorization is going to get required. And so from that point of view, the requirement of the proxy signatures will be there. So to give you the real life example, that most of the banks or banking authorities, wherein, not authorities, the banks, wherein the software agents are used to perform this sort of verification operation of the customers, clients, they are implementing it through proxy signatures. So the customers of the banks, they are required to verify. So you have some agents which are running in the background who are doing tasks on behalf of the original user or original authenticated person. So in most of the finance domain, the work of proxy signature is there. Means if you could go through the research proposals and papers which are being there on the proxy signature, the implications and the applicability is in the finance domain. So we found out that similar sort of things, not in terms of what sort of delegation is required, but in terms of what sort of document verification is required, is similar in e-governance or in process of making the banking system, or you can say a net banking system for that matter. You must have seen, experienced that even without visiting to a particular branch of a bank, I may be issued with my bank account number. So I am giving my proofs and I am issued with a bank account. So there is no necessity anymore to go physically over there and do it. So what is working in the background is all those software agents which are finding out, verifying and performing the things. So in the entire work, what I found out that e-governance is one particular such area which is in the process of transformation and which may be requiring, as and when it will progress ahead, it may be requiring more amount of this authentication to be performed. So document authentication or document authorization is required. So all those applications could be clubbed together wherever the delegation is required in terms of proxy signatures. So there is where the concept of there in the cryptographic algorithm which makes public key crypto system work. It may sound that I am only playing with numbers, but yes, wherever it is possible, we will be trying to relate it to, like in a delegation, we wish to perform a delegation in terms of the role. So I may be referring or representing that role with some numeric value, or I may be trying to relate it to some numeric value so that my further operations could be understood or could be performed in an easier manner. So most of the times if you look at the proxy signatures, they are the derivatives of the original digital signatures. The meaning of derivatives is that you need to have or you need to develop the mechanism which will let that the original signer could give his part of the private key or could delegate certain information which could help in generating the private key to the delegate, and then delegate will again perform some set of operations to generate the algorithm or to generate the keys and further ahead use it. So what we focused or what I thought during that period, that the role-based delegation is more important, that I may be working in some particular scenario or environment and I may be interested in delegating my role, specific role. So as I said, as a teacher, as a course in charge, as a head, I may be having different set of roles, and for that I need to delegate that work to someone, either as a person or as an entity to someone else. So the focus is how this could be achieved with or in terms of the signature operations. So things which will lie in the background of generation of the proxy signature. So for time being, what I will do is I will skip this slide and move to the. So you have these operations which are irrespective of whether it is your digital signing or verification operation or your proxy signatures signing and verification operation, it is going to remain same, that you need to have certain algorithms which will work in the background, which will help in generating the keys, which will help, or that you call it as the public key infrastructure. Then there will be certain set of operations which will be helping or which will be there generating the certificates or implementing the certificate standards, generating the certificates and then utilizing it. So you have some sort of signing algorithm, verification algorithm, then you have some set of key generation algorithms. So the main focus of the entire proxy concept is related to when you wish to delegate, and not only delegate your rights of signing, but you wish to delegate the rights of signing with respect to some specific role. So I hope this is visible, so you can focus when you are filling. So you have that concept, now you have that thing in the background that whenever I wish to delegate to someone else in terms of on performing digital operations, it may be related to delegating the role. So now for time being, assume that you are working in your lab and you have some authentication system, like you have to log in, you have to provide your username, password to get an access. So someone, your friend, wish to access your documents through your login. So what you do, you give her entire username, password, and you ask her कि यहाँ पे login करो, यहाँ पे ये रखा है, and so on, right? Now what is essence of proxy signature, or what is that? That if your friend is doing some malicious work in your login, malicious work means you can consider it as deleting of some files or adding some malicious script into it or something like that. Will your security system be able to identify who is the one who has compromised or done mischief? Majorly no, because you have given rights कि ये मेरा login है, ये password है, देखो, right? Because you thought you have some confidence in a person and you can do it, or he or she may do it without disturbing the contents what they are there in your drive or your login, right? So that whole concept is related to I have a confidence in a person and I am giving him rights. So why to give that access anytime any document which is present in my login. So that has given right to, I am going to give you only partial rights. So it is that when you are accessing through my login, it will be noted down that who has logged in. So it is not with my name. So it is not with the name, even though I am giving you rights to log in into my drive. But it is not with my name. It is with your name that you are going to log in. It is with your password that you are going to get an access. But yes, you can access contents which are there in my drive or my folder or something wherein my authentication is required. And then, do I am going to provide an entire access? No, it's not like that. You are giving some certain specific view. So giving a right to a specific folder within that drive, or you are going to give a right to some specific set of files. So I may be asking someone else to only modify certain Word files. So he may not be given access with different other files which are existing. So he may not be given access with what are there as my result files or admission files or something else. So I am giving restricted access. So now very obvious question that may come to your mind is then why do we have that all the definitions of the roles which are there with which we are providing privileges, like student have different set of privileges, faculty has different set, manager has different set of privileges and so on. So here the essence is not that I am restricting or I am not accepting the privileges which are coming over with different roles, but here the thing is I am trying to give my privileges to someone else. So whatever privileges are there with me as an entity, so as a privilege as head of the department or as a privilege as a manager or as a privilege to access, perform certain operations on the file, I am giving that limited access to the next person. So what if instead of the name, all these operations are or all these accesses and the privileges which are assigned, instead of the name, what if it is being performed with the help of the role? So what is that means to me? So I have suppose 12 teachers in the department, everyone has got same role to do. So how do I differentiate between the role that this teacher is performing and another teacher is performing? As a supervisor, if I am having certain specific role, then how do I delegate those roles to someone else? That these are the restricted roles which you are permitted to perform for so and so duration of time. So that is where the proxy signatures will come into being. So what I mentioned previously, I may be reiterating it again, that you need to have some set of mathematics, cryptography, which works in the behind, which helps me that even if I am having some partial signature. So there is some concept called as a partial signature or a partial private key or partial public key. So that partial signature is only a part of my contents which are separating out me as an individual from someone else. So what works in reality is that your e-governance system is using all the signatures or the signature standards which are based on the individual's identity. So they are not majorly based on the role that is being played by an individual in an organization. Are you able to relate? So if you are a teacher, you are given with, so my login is Aparna, I have some password associated with it. I am not given with teacher 1, teacher 2, teacher 3, something like that. So the moment I am saying that it is with my individual identity, I am given with the privileges or some sort of accesses, then it comes that what is to do with my role which I am playing over here. So what if I wish to delegate that role? So how do I do it? So you have a solution in terms of proxy signatures existing, but what those signatures are doing, they are again relating you or to whom you are delegating the things in terms of the identity. So it is not in terms of the role which you are playing in the organization. Correct? So here comes the difficulty of the problem, or you can consider it as how difficult it could be, because if you look at an organization, you may be having n number of people who are given with same designation. I may be having 4 or 5 different managers in a company. Maybe they are even with different departments, or within a single department there might be hundreds of projects going on and everyone is calling I am a project manager, I am a project lead, and they have same set of privileges assigned to them in an organization. So then there comes that if at all this sort of signing operation, verification operation, the agents are to be performed or they are required to do, is it that just considering the role will be sufficient when I am performing some sort of delegation operation? So these are some specific, if you are able to read the slides, these are specific things that digital signature standards are implementing. That for authenticating that someone, proving my identity, when I am using the signatures, it could be related to some sort of username, password or OTP, what I am having, what I contain, or some sort of biometric authentication. But when you are looking at the higher level of implementation or looking at the larger aspect of it in terms of delegating your roles or rights to someone else, we need to think of that this identity, whether it is sufficient or not. This way you are doing authentication is because it is that I have registered mobile number and through which I am going to prove that this is the OTP and I am going to authenticate or I am going to relate it. Now when you are doing it as you are providing your you are delegating your task to someone else, then how can I do it? So these are some set of difficulties that will come into or that will arise when you are talking. I am not very sure whether this is readable or not, but I will just show you how the typical operation works. That you have the e-governance system wherein the citizens will submit some of the applications. They will be processed by the backend system. In most of the cases, the backend systems will process it and perform some sort of manual operations in terms of verification. You must have observed this during your when you are withdrawing money also. On your check, your signature is verified on what is present in on that clerk's desktop as a signature. So she will be doing a manual verification and then she will be approving, yes, this is the same person, and could be given to could be issued with further things, right? So that manual intervention we want to remove it. I am just giving you examples so that you could able to relate it. So what is e-governance system is doing in background is again same thing. You have some applications which you are submitting, maybe a digitized copy, but the system which is running behind is performing some sort of manual operation. And then they are issuing the signature, signing on it, and then submitting, and then the certificates are issued and so on. So you have some of the things which are working in the background, which work still in a manual fashion, right? And you need to do that, or when you are looking into the automation wherein you are trying to process whole lot of applications in a shorter duration of time, your aim would be how you can automate these processes. So if I have some already stored document and these documents are to be checked, verified, so then comes the concept of your OCR and then accuracy associated with how you check your documents. So my point is further behind that what if these documents are verified and everything is there, but the signing authority is not there, so who is going to do it? So that comes as how you can then perform the operation. So this is just the concept of how in a typical way the signing and verification operation occurs. So the few things which we identified as a part of difficulties which are there in terms of manually or digitally, not manually, so the major focus will be on the digital signing operation. Usually a huge amount of lookup is required. So what is that lookup is referring to? That whether the signatures are being issued to that particular entity, and so the certifying authority has to perform that lookup whenever the verification operation is going on. So again I will try to relate it to, so I have some documents, a birth certificate ready with me, which is digitally signed, which I am producing it in some XYZ office. So how do they do it? As a verification operation in an actual signature verification is, they will process that entire document in terms of some ID which is being given, and that ID is cross-checked with the set of digital certifying agencies who have issued that certificate, and whoever is issued with that certificate, what is the corresponding ID which they have issued with. So there are whole lot of, you can say, indexes or the levels of indexes which are indices which are associated whenever there is a processing operation involved in it. Are you able to relate it? So huge lot of processing is also required whenever the verification operation is going on. So the thing is, what if in this some sort of delegation is being brought? So some sort of proxy is being brought. We will be adding one more level of delegation to it, right? Or sorry, not delegation, one more level of search to it. So already I may be having 3 different levels of search. To that, this proxy delegation is adding to one more level of search. This may also happen. And so the implementation system should look or think into it that with existing system, with existing way how the verification is performed without giving much stress. So here the stress is on computation. So without giving much computational stress, if the same thing could be performed even for to whom you have delegated your rights, that may work. That may work means it can be adapted into your system very easily. So there comes the proxy signature with role-based adoption. So you have to focus, or the concept here is to focus on what is the role, and based on that particular role, how the signatures could be generated. So to quickly bring you back to what the session is going on, anyone could tell me what is your perception, what you have understood as a proxy signature? Last, I think they are students. All are faculty members. Oh, sorry. So someone could tell what is your perception, what you understood as a proxy?
We can say that it is the type of power of attorney given to somebody else.
In the digital platform. So, yeah, at some point you are correct that some rights are given to some entity. That entity could be person, that entity could be system itself. So, on my digital platform, whatever is possible. So, it could be entity, it could be agent, or it could be set of entities to which the delegations are given. And the reason behind that, that I wish to speed up all the processing work, that could be one. I wish that the things should not get pending, so that the entity is not available. So as if I am saying, if the software agent is doing some work, he may be in a position to delegate that to some other, like how it happens in the web services. So it may be possible up to that extent also. So what is difficulty? As I mentioned previously also, the domain majorly where the proxy signatures are used is finance domain. And the finance domain is most crucial, or you can say sensitive domain, wherein we need not, or we do not expect that some sort of inaccuracy is tolerated or something, and still in that the proxy signatures are major things which are being used. So the reason is that when some researcher or someone, say for example I have digital signature standard which is being defined, on similar lines if I have a proxy signature standard which is being defined, the standard has to ensure that the things which are working in the background should have these characters, that it should be unforgeable, should be identifiable. So the meaning of unforgeable is someone should not be able to create a forged proxy signature. The replica of it which works in the same manner and no one is able to detect, identify it. Then it should be identified. So who has created, and who has created the proxy signature, and who has given the rights to create. So these things should be very much to be represented by on that signature certificate. So if you could relate or remember, I don't know, I am not expecting every one of of you to be in the security domain, but most of us do listen to, or we have that idea of X.509 as a signature certificate standard, and they are given with certain set of fields which are necessary or important fields which are there in the. So it mentions about who is issuing, what is the expiry date, when it is being issued, and whole lot of details are there on the certificate. So that makes it identifiable, that which certifying authority has issued this. So it makes it identifiable. On the similar line, within that certificate, if you are generating some set of proxy, it should be identifiable, that certificate itself should give me details that who has created this proxy, for which duration it is being generated, and for which sort of operations. So I said the delegation is partial. I am not delegating it entirely for all the whole lot of work which I am doing with my role. So your delegation is partial. So that becomes an identifiable. Then undeniable means it is more related to if some sort of dispute arises. So I am delegating my rights, and someone else to whom I have delegated all of a sudden is saying that I haven't done that, or this signature is not mine, and so on. So that not, or you can say it as denying that this particular work is carried out by me, should be restricted. So you need to have, when you are generating the proxy signature, this important feature that no one should be able to deny later on that this is not the signature generated or signed by me. So it has to have. So these are the important, or what you call it as the characteristic that every proxy signature algorithm should have. So it should be verifiable. So as the verification algorithm works, it should be able to relate that this is related to that particular proxy or that particular original authority who has given proxy operation, and this has been performed. So in the domain of security, or rather in the domain of cryptography, it is found out that developing some certain algorithm which satisfies all these 5 different properties is difficult, or rather, instead of calling it as difficult, it is up to the extent not possible. So there are very few algorithms which will try to touch that. Up to certain extent it is able to satisfy all the characteristics. So what is expected, this is, you can consider it as these are the probable, or these are the good conditions that your proxy signature algorithm which is being generated should satisfy all these characteristics, but this is not real life condition. So you do not get all the algorithms or the cryptography which is working in the background will be able to prove that it is unforeseeable, undeniable, identifiable. It is very difficult. So when some set of proxy signatures operation has come and are required to be implemented in real life. So as I said, some in the finance domain for delegating the rights, say e-checks are there, and I am delegating the right to someone else to issue the check to the bank and sign on his own, and the bank will issue him the corresponding money. So in this entire operation, it becomes for the banking authority to check that some dispute should not get raised later on. Someone should not come back to me saying that this is not the check which I have issued, and so on. So satisfying all the characteristics in the manner which is expected is difficult in the real life scenario. And so the various proxy signature algorithms which are there, they have to mention that which amongst these features are applicable to their proxy signature, so that the implementation system can implement some other aspects of security to ensure that there is a undeniability, or there is some sort of verifiability, and so on. So is it clear to everyone that it may be that the maturity with which the digital signature standards have evolved is quite a lot. So they have become mature system. And as I began the talk, we mentioned that these are all the places, or these are all the day-to-day events wherein we come across the digital signatures. Because of these restrictions, that it may not be possible that I am implementing a proxy signature to give my rights on the digital platform, and at the same time I am able to prove that they are all satisfying these characteristics. May be difficult in real life, right? And then when I am implementing, I am investing on making a proxy signature certificates and so on, and then I need to have some different security measure for the rest of the things which are not being covered. It may go quite an expensive affair, right? So it may become expensive than what is permissible for a common man to use in a day-to-day life, or the taxes which we are paying for the services which we are getting and so on. So this is one thing. But yes, the necessity that we wish that I am taking typical scenario or particular scenario of e-governance because wherein huge amount of document processing verification is required. Yes.
Is there misuse of the digital signature? How that person will know that if there is any misuse?
So digital signatures are in a way difficult to misuse because if the certifying authority has revoked from a particular person the signature which is being assigned for the rules which are violated by him or her, by the professional, that goes into the revocation list, and the reasons of revocations are mentioned. So whenever the verification is going on, they will first check in the revocation list that whether this signature is from the revocated list or not, and if it is from revocated, it will not be further processed. If it is not from the revocated list, then as I mentioned, there are n number of levels of indices through which it has to process. So that, as I mentioned, signature algorithms have or these standards, not algorithm. So that standard may be using any n number of different algorithms. So that digital signature standard has become quite a lot mature. That forgery of that signature, or as you mentioned, the signature is in the revocated list and still the person is using it. This is hardly possible. So that signature standard has become to that maturity level that it has tried, tested all the flaws and it has patched up those flaws. So when it was evolving, I will not say that at the time of the evolution of digital signature there were not drawbacks or flaws. They were existing there. Like the amount of time it takes for revocation, the amount of time to bring that the certifying authority is identifying that this signature is to be revoked because of some rules which are not being followed, and then lookup to be performed on the revocated list and so on. That was quite taking a large amount of time, and then came the distributed systems and implementation on that, and then replication algorithms. So that has reduced quite amount of time. So this is the thing which is in digital signatures. As I said, for becoming equivalent maturity to the proxy signatures, it may take around time because the algorithms or the signature standards are not that mature enough to provide all the security features which are required. And so, I am not sure whether you are able to come. So, these are all the types of different types of proxy signature algorithms which are being developed, designed by the researchers, that either you are doing a full delegation, you are doing a partial delegation, or you must have heard of the key sharing or sharing of keys, right? So you have shared keys, and if I am having all the members together, then only that particular key could be clubbed together and generated. Otherwise, it may not be possible to identify myself even I am carrying a part of that share of key. So there is one particular very interesting implementation of it, that most of my documents data is now available on my mobile device, right? And if that mobile device is accessed by some illegitimate user, he may be in a position to get all my records, and possibly he may be impersonate me anywhere, right? So you can do what is, you have multiple mobile devices, you can keep your shares of the keys on multiple devices, and if you have those keys available, then only you can access a particular folder. So even if tomorrow my mobile is stolen, he or she may not be able to access any of the data which is stored over there. So that shares of the keys are also there. So cryptography has matured enough in that way also. So these are few, you can say, derivatives the proxy signature. It is majorly looking into the toughness, difficulty with which the signatures are being developed. So you have some integer factorization problem or discrete logarithmic problem, due to which the inherent nature of these problems are making these particular algorithms strengthen, or they are making it themselves strong enough. So you can, those who are willing to, or they are in the domain of security, they can also go into depth of threshold based security. So the keys will be shared by multiple people and say 4 or 5 users, and more than 3 users are giving their keys, then and then only that document could be accessed. Otherwise, so there is some threshold, that n by 2 or n by 3 could be a threshold setup with the help of which the users can access the document or the signed elements. So these are few, this particular diagram which I took it for the understanding that how the original signer will delegate his or her rights, and then the proxy signature scheme will be utilized or used for performing the signing operation. So what will run in the background is equivalent to how your signature algorithm works, but there will be on top of it one more module will be there which will be working as a proxy signature generation and what you can call it as verification operation. So you need to have whole lot of same state, like I may be having a certifying authority and then set of rules, and then the repositories wherein the signature certificates are stored and cross-checked again that. So if I am introducing a concept of proxy, then I require a whole lot of that infrastructure apart from the certifying agency's infrastructure. So if I am getting some advantages, at the same time it is that the load on the infrastructure, load on the processing has also multiplied or has been multiplexed, that the proxies are to be first checked for its verifiability, then to be given to the original signer, then the certifying authority will check. So if you could understand the depth with which this problem is to be handled, that the government will not be ready as it is that the load on it to be multiplied, so that they have to check certifying authorities as well as they have to check for who has issued proxy and whether that proxy, revocation of proxy and all other things. So you need to have some robust algorithm or the things which are running in the background which will automatically check it, that these are the proxies which are to be revoked, these are the proxies which are not to be revoked. So I will come into that further as I move. And in case of, so this is one step further ahead. I know that many of you may not be able to relate it to, but yes, the forward secrecy is that which lets that suppose tomorrow you are the owner of the proxy signature, not proxy signature, the digital signature, and due to some reason, XYZ reason, you have compromised your key. The meaning of compromised your key is you have shared it with someone. So if you have a digital signature, it is the rule that you are not going to share it with someone because it is your private key. It is rather not accessible to anyone. If you could see, if I am having a digital signature stored on this device, it is stored in an encrypted manner. I am not able to access it, I am not able to get. Many of you must have, those who are teaching cryptography may have implemented a PGP protocol, pretty good privacy. And you could see that there are a lot of things which will show that this is how your signatures will be stored on the device, and not signature, public private keys will be stored on the device and how you can access it through certain mechanism. But I may not be able to any time in my lifetime will be able to get that exact value of the key which is being generated. So assume that I have a compromised device. So anyone who is having access to my device can access my private key and perform his work. Now later on, when I am taking control of my device, I am saying that these are not the things which are being done by me, and so there is a dispute. So what is forward secrecy is saying that your signatures will be assigned for certain duration of time. So you have a private key which is assigned to you for certain duration of time. As the time will elapse, you will get a different signature, or you will get a different private key. But the verifying authority need not have to worry, they will be able to verify it with the same thing that they were doing it for previous private key. Are you able to get again? So I will repeat it. So what is forward secrecy is referring to? So as I mentioned, in a public key cryptography, you have some public key, private key, and they are multiplicative inverse of each other if I am referring to specific algorithm of RSA. So for one public key, there has to have only one private key. What is forward secrecy is saying that there may be some disgruntled employees who are compromising their own keys, and so the organization may be in a problem and we want to assign this particular set of employees only for certain duration of key signature certificate. So what is assigning of the keys? They have their private key on their devices which are whitelisted and so on. So that duration is specified and they are signing it, someone else, some other authority is verifying it. Necessary नहीं कि आपके office में verification के लिए documents आए, can be anywhere else. So your verifying authority do not want to take that burden that when your private key is changing, they also have to change their key with the help of which they are verifying. That is none of their duty, or that is none of their issue, problem. Because you are changing your private key, they should not get suffered by that. So what is forward secrecy is saying that even if you are changing your key, we wish that your public key will remain same. So those who are trying to verify your documents will not get affected. They can do it. So suppose I am issued with a key for 10 days. Someone else, so my private key is changing. After 10 days I am getting different private key. Then again I am signing some document. So verifying authority is not bothered. It can verify it with same public key. So this gives rise to something called as a time evolving keys. So your keys which are actually used in the digital signatures or in reality, the applications which are using it in a time evolving manner. So for the verifier it may not be a issue, problem, but for the issuer who is issuing a certificate or who is issuing the keys, it has to ensure that for this duration this particular is a private key, and for the next duration it has to evolve from the previous key. So that there will not be a burden again on the certifying authority that they have to go on generating the keys as and when the time elapses. So suppose I am given with some designation in an office for 1 year of span, and I wish that, or the authorities, higher authorities wish that after 1 month whatever documents I am signing, that signature should get changed after every 1 month. So for 1 year of span, I may be issued with 12 different signatures. Are you able to get it? So because that whatever I have signed with the previous documents for first 1 month, and then I am a disgruntled employee, I am giving it to someone else, my signature, and I am asking them to check karo ki pehle kya sign kiya hai, and so on. So in such case, this signature which is in a forward secure manner will not let that if the duration has elapsed, you cannot make use of that previous private key. Getting it? So even if I am a signing authority, I am a disgruntled employee, I will not be in a position to make use of that previous private key which is given to me because the time duration has elapsed. So this concept is called as forward secrecy. So what is that? All your previous documents which are signed by a particular private key will not be accessible once the duration is over. So if I am given 31st day है, 30th day का मुझे duration दिया है some private key का. So 31st day I am trying to sign it with the same key. I am not able to because I am issued with new. If I am saying that this is the document, please cross check it with that. I am not able to do it because my private key is changed and the system is not letting me to make use of that previous private key. So you have the security associated with, security means confidentiality, integrity, non-repudiation, because that is the major thing with signatures. So that you are going to provide it for all the duration of time for which your signature is being issued. So in reality, the digital signature standards do work in a forward secure manner. So though they have revocation list available available at any instance of time, the digital signature which are stored or the private keys which are stored on the devices, they do change. So you must have seen many, those who are working in a higher security zone where the security requirements are very high, they are using the wearable devices, and on those wearable devices they have RSA keys through which they can work for that specific day. Have you seen any time the wearable devices wherein some security keys are stored and then those keys are changing every day or every week? So those who are working in a higher, where the documents or the information which their devices are carrying requires higher level of security, there you have to set that the duration for which I am able to access this data or this information is only for 1 day or for 1 week, and they are being issued with specific wearable devices, and those wearable devices will give them the keys which are required to access for that particular day. Like how you get an OTP for 15 seconds or 30 seconds to prove who are yourself, right? So on the same lines, the IT industries do issue such kind of wearable devices that the duration is only 1 day, that I am able to access my documents only for that specific day. And you must have also been familiar that when these IT people were working from home, they were trying to remotely log into their servers, they were proving their identity, and they were trying to access their production servers, right? So how they were doing their proving of identity or proof of identity? Many of your relatives might be working from home, right? So merely username, password, remote access is not sufficient, right? So those who are working on the project where the production data is stored, you could see that they are given with certain either devices or they will be getting some mails wherein they are given with the keys which are to be used for that specific day. So the security systems have evolved up to such an extent that you need to protect, and you need to protect in such a way that if some compromise occurs in further, like my previously secured documents should not be altered or they should remain secure. So that is what the concept of forward secrecy is. And then come this particular aspect, that how usually signature certificates are issued or what sort of algorithms to work behind that. So many of those who are in cryptography system security domain might have heard of integer factorization problem or discrete logarithmic problem and so on. But in both of the cases where public key cryptographic algorithms work, they have requirement of huge computations. Why do we call it as discrete logarithmic problem? The very essence that we need to perform the square root of the or the cube root or nth root of the given key to find out the corresponding public or private key. So that is what, and that to be performed in a modular arithmetic or in a modular manner. I will not go into the depth of those algorithms because that is quite boring for those who are not from this particular domain. But yes, the essence is that it is difficult to crack the algorithm or the system by the time there is a need or that data is carrying some meaning. Correct? So that is what your cryptographic, majorly cryptographic algorithms are. So if my results are to be out tomorrow, the need for security is till today. Right? So I need to implement some such security mechanism that I need to keep it confidential only till today, because tomorrow anyway it is out. So even if it is accessible to anyone else, it does not make a difference to me. So same is the case. What is your integer factorization problem is saying that for a specific duration, your system may not be able to find out which is a particular prime factor for the given huge large number. And that is the entire essence of your cryptographic algorithm, for which it is working in a secure manner. But then we have come up in the era wherein we have high performance system, then we have parallel systems which can process on the data parallelly and give the results very efficiently. And so you need to have some such things which has a difficulty level of cracking even more than what your parallel systems or parallel algorithms could achieve, or what your distributed systems can achieve in a distributed manner and give the results. So there comes the, what you call it as, overcoming the limitations of what is discrete logarithmic algorithms are providing or integer factorization problems are providing. So you could see that many of the implementations, like cryptographic algorithms which are implemented in a real life on certain devices like a wearable device or any other devices, you could see that they are no more using these problem statements or integer factorization problem statement based algorithms are not used, but rather they are used on a different domain called as elliptic curve cryptography. So ECC is a more evolving domain. ECC has also now become obsolete, and there is hyperelliptic curve which has again reduced the number of computations, which has again reduced the number of operations which are required, the processing which is required. So in thing is now hyperelliptic curves. So the elliptic curve cryptography has in a way reduced that the requirement of the processing or the processing power requirement, and so your ECC cryptographic algorithm could also be implemented on the small wearable devices. So you may have your mobile phone which will be working as a key generation center. So you know that there are limitations with your mobile processing, and still it can work as a key generation. It can generate the key for your circle of the proxy operators. So this is how the public key cryptographic algorithms are evolving. So then comes this major thing that what you try to do when you are doing a proxy operation. So either you are trying to delegate the roles, or what you are trying to do is you are trying to give your power of signing authority, and you want to do it in a manner that it is providing an end-to-end solution. So the simple meaning of providing end-to-end is it should satisfy all the five criteria of proxy signature. If it is able to, my work is done, I am able to do it with only a single algorithm. You do not have to go for 4 or 5 different set of things. So to adapt to the proxy signature, what is the requirement, and then to develop that multi-level proxy means I want to delegate to you, you want to delegate to someone else, and the third person want to. So there are hierarchies, and then that comes with that some sort of a number of keys which are to be handled, managed, and so on. And as I said, the original certifying authority is not interested in whether you are interested in delegating your power, and we need to manage the whole lot of infrastructure. So you need to do it with on your own. And with the in thing, we can do it instead of doing it on using RSA kind of algorithm, or using the one which are based on integer factorization problem. It should be based on the elliptic curve. The very essence of using elliptic curve for some such operations is that it is very easy with a limited computation power and the energy to execute these algorithms. So as I said, it is possible that my mobile device can work as a key generation center. So they do not have to have huge amount of processing. The thing which works behind is that whatever you are doing as a integer factorization problem or discrete logarithmic problem has come down to integer addition and multiplication in the elliptic domain. So the extent up to which the operations are required are reduced quite significantly. It just comes out as to be addition or multiplication of two numbers on the elliptic domain. So the only thing which is important here, if you could see this, that you will be generating, if it is a role based proxy signature, you will be generating the keys which are based on the role. So the very thing which with which I started the speech, that I am working as a teacher and there might be 10 different teachers, and how do I differentiate between my role and the other role? So creating the signatures only by being a role or based on the role is not going to be a complete signature, which will be verifiable, undeniable, identifiable and so on. So then comes that you need to implement your things by using or considering both the things, that you need to have somewhere identity associated with it, you need to have somewhere a role associated with it. So the whole lot of thing goes that where you exactly take into consideration the role and where exactly you take into consideration the identity. So what you do is you have to have a signature algorithm developed which will work in both the manner. So you take of the partial keys. जैसे मैंने आपको बताया था कि partial keys is you have a key share at one device, another key share is at another place, and if you have to mix it, then only you are accessible to access that device or a folder. Same thing, you have a role which is defined and you have an identity for which you are already been issued with signature. So what you have to do is you have to mix together your role and your signature or the part of the signature algorithm, you call it as the partial signature algorithm also, so that the new signature which gets generated, or you call it as new private key which gets generated, is able to represent both the role as well as the identity associated with that an individual. So is it going tough? Somewhere you are able to relate. If it is tough, let me know, because the topic is little bit that way. And you have to imagine, you have to envisage that this may happen, this may be the case. So the immediate question will be, if there are 11 teachers, whether all the 11 teachers will be generating their own proxy signature with their identity, or 11 teachers will have only one proxy signature with their role as such. So the answer is, I want to delegate my rights, so I have to create a proxy, and so it will be associated with my role as well as with my identity. And why it is being clubbed like that? Because you need to have those characteristics, otherwise no one will use your proxy signature. So you need to have undeniability, identifiability, so no one should deny later on that I haven't created this proxy. So you have these constraints which leads to development of certain proxy signature algorithms. And this is some specific, I will take this slide first. These are some specific implementation aspects, like what if I want to implement the proxy signature, it may go haywire if I am not having the key management system associated with it. So most of the times when we teach public key infrastructure to our students, we forget to mention or give emphasis on what is the infrastructure which works in the background and how that public key infrastructure works, right? So same is the case that when I am using the proxy signature, there has to have a whole lot of infrastructure which works in a similar manner how certifying authorities work. So there has to have someone who is identifying that this particular is a role generated, who is going to identify that this particular is the proxy which is generated, and the verification operation is to be performed. So this particular is an example where I took that there could be multiple levels of delegations which may be required in the real life. Though this is very hypothetical scenario, even the cryptographic algorithms do not allow many number of times some such sort of multiple delegations. At certain levels, when you are implementing signature algorithms, when you are working on digital signature algorithm, it is quite possible that you are sharing a part of your private key and the other person is asked to generate his or her private key based on that key. So there is a dependency on the multiple levels of the keys which are getting generated. And there could be a revocation list that if the highest authority is revoked, rest of all the signatures are being revoked from that particular list. So then I have already covered with the forward security which is related to the role-based delegation. So I will move ahead. I will not go into the algorithm as such because this particular is a specific work which is carried out in the process of development of the algorithm. Those who are interested giving some sort of inputs with respect to what could be proxy signature and where it could be useful. So this I will be skipping for time being, and I will go to the framework which is being designed. So the framework which is designed for the proxy signature has some sort of intermediate, or you can call it as some sort of sandboxing environment. So sandboxing environment is going to check that in security you must have heard of sandboxing environment, right? So if some mail comes to my inbox and I am doubtful that whether this mail is a junk or some sort of malicious code attachment or so. So what you do is you open your mailbox, you execute that file on a sandbox, and then if the performance in the sandbox is okay, that this is a normal file, it is not showing some abrupt behavior, it is not showing some sort of huge amount of CPU utilization or memory utilization, you can consider that this is a normal mail, even though the subject line is showing that it is a junk mail, or even though the attachment is showing that it is a huge file or some, you can call it as some sort of words which could be objectionable are coming. So still it is not junk and then could be accessed and so on. So you have certain mechanism. So this particular is same. Instead of finding out whether it is a malicious or not, what we did is we created a sandboxing environment wherein it will create a proxy which is based on the role, and which will also include the identity, and this intermediate middle level will store that how many some such proxy keys are generated, to whom they are issued, and whole lot of information. So that processing will not be done at the certifying agency or authority's end, but will be done at the intermediate level. So suppose tomorrow in my organization I wish to implement proxy signature, what I will have to do, I will have to have some delegates who are being already issued with proxy, who are already being issued with signatures, digital signatures, and they will be giving it those things along with the intermediate application which you have developed or which is developed, will be generating the role-based proxy signatures. So this sandboxing will create n number of different proxy signatures wherein the certificates will be maintained with respect to proxy, and whatever operations you are performing in your organization, that is, for example, you are doing some signing operation or something, so it will be related to cross-checking with your organization's intermediate middle layer. So that application will cross-check as and when there is a verification required. So this added thing is done by your sandbox environment or your environment, middle layer environment which you have developed. So on a large scale, if you wish that how my digital signature works, on the similar lines, if you wish to have role-based or forward-based proxy signatures to work, it is in reality impossible. It becomes hypothetical because certifying agencies are different. They may not be taking an individual organization's proxy operations, right? So if it is a land registration and there they are doing some forward delegation, if some other e-court is there, they are doing some role delegation. So why certifying authority be burdened with processing of all that? So you need to have for implementation for an individual organization their own structure which will take care of this. So there are these, you can consider it as limitations of your proxy environment, that as the new features or facilities are introduced, so will be the new, you can say, security loopholes that could be introduced, so some new security burdens, or you can say processing, over processing is required. So is the case with the proxy signature, that if you are implementing some sort of role delegation or so, it has to have come up with larger processing which is to be done in an intermediate manner. Yeah, so this usually, it may be very general statement that whenever security algorithms are there, they are to be checked for two things. That is the performance. What could be the meaning of performance in general?
Efficiency of work.
Okay, efficient, how efficiently it is working. generated or not, and so on. The performance in majorly in terms of security algorithms is related to whether I am able to achieve the same thing with lesser amount of operations. So I am not saying that I am changing the outcome to be checked with what is expected. That verification is required, but that is not what your performance analysis of the algorithm is trying to tell. So what majorly performance analysis is trying to tell is someone has developed the algorithm. Suppose RSA algorithm है, encryption के लिए मुझे I have to perform the exponent operation for 2 times, for key generation 3 times. My modular operation is to be performed 4 number of times. I am just telling example. So is there any other algorithm which is existing which will be able to perform this same thing with lesser amount of or lesser operations? So because the whole lot thing is again related to. The whole lot thing depends on how efficient is your computational devices.
Time complexity or space
Yes.
complexity.
You can consider time complexity of the specific algorithm. Also, the more is this, like we usually say, or you must have heard that the RSA algorithms are almost, or the RSA implementations are almost obsolete. Obsolete means industry is not using it. So the reason behind the sort of the very first public key cryptographic algorithm not being used as a standard, any standard, is that they are very computationally very expensive. You have a lot of modulus operations to be performed, lot of exponent operations are to be performed, and so they become very expensive computationally. So the performance analysis of any cryptographic as such algorithm where you are actually implementing some cryptographic operation majorly depends on how you are reducing that task of computations. And that task of reducing computations is most of the time depends upon the domain which you select. As I said, if I am doing same thing on elliptic curve instead of integer factorization, taking z and n. Zn is the first thing that we try to learn. The set of integers and then performing operation on that. So instead of that you take an elliptic curve. So your whole lot of complexity reduces to addition or multiplication in that particular domain. So those who are from image processing, I think they will be very easily be able to relate. When performing some operation of processing the image on the spatial domain, maybe taking whole lot of computations, right? I have to process pixel by pixel. The same thing if I am doing it in the transform domain, be it a cosine transform or any other transform, Z transform, I am doing it on only few coefficients in the transform domain. Same operations I am doing it and I am able to get the good results. So you are reducing number of computations when you are changing your input into some particular domain. So the signal is same, you are changing it from spatial domain to the time domain. Same is the case here. If I am using RSA, it is integer factorization problem. I am working on Zn, set of integers, with modulus something. When I am working on elliptic curve, I may be defining some sort of curve, and all the operations which I am performing is based on addition or multiplication on that particular curve. So when the algorithms are implemented using ECC, or to be rather on what is in thing going on, the hyperelliptic curve, it reduces the complexity of the operations up to a good extent, and so you get it as a more efficient algorithm. So here I have deliberately removed that one particular table I have placed, but I thought it may be difficult for those who are not from cryptography domain to understand that how total number of addition, multiplication and reduction in that eventually improves the performance of a system. Security analysis is in a very basic way. You can consider it as to the triad of CIA, or if it is specific to the signature algorithm, you can refer to those characteristics which are required, like identifiability, then undeniability, correctness, and so on. So those are the 6 properties against which any security algorithm in the security model, or you can say this domain, particular domain, is evaluated. So what you are saying is that whether I am expecting some sort of output and whether that algorithm is generating that output or not, that verification could be done as a part of security algorithm. There are a lot of other domains wherein this security or security parameters are cross-checked. Like as I mentioned, computation is one major when the performance parameter are checked. Security parameters, here we haven't taken into consideration, or I haven't mentioned, or I haven't covered it over here. That the security when your data is at place and when it is in transit and when side channel attacks are there. So a whole lot of that is to be taken into consideration when you have an algorithm which is to be implemented as a full-fledged product which will work for the signing and verification operation. So these are few applications of the proxy signature which I went through. Could be related to the forensic investigation operation. So majorly, I think myself and Rachna madam, we have worked on some sort of evidence handling, how those evidence handling things could be handed over to the investigating officers in terms of generating the proxy signatures. So there are things like investigation of the frauds and detection of the forgery, where majorly impersonification could be one of the things that the attacker has performed, and you wish to identify that how that impersonification, or I am not saying impersonification is the only thing through which the frauds are being carried out, phishing and other things could also be there. So majorly these signature algorithms, if at all could be used, could only be up to the extent in the forensic for the forensic investigating agency. So you, during this entire STTP, you must have gone through the different aspects of evidence handling and other things. So if at all the human evidences, or you can say the evidences which the human or the investigating agencies are handling from one authority to another authority, all the things like when, which sort of evidence, whether it is a soft evidence or other things, are being handed over to the next investigating officer without what you can call it as changing the contents, or without interrupting the integrity of that particular thing, could be implemented by using the proxy signatures. So here when one investigating authority is handing over the evidences to the next person, they could very easily make use of the proxy signatures, and then the safe copy could be kept easily separated out, which may not be accessible to anyone. So for that there will be a different signature, and for these which are being handled by n number of different people could be used through the proxy operation. So at any time you can verify that these are all the investigating officers who have checked into this particular soft copy of the content, or it could be any evidence, it can be any other device or any other evidences. So majorly the evidence handling and the signature authentication by the forensic document examiners. So again that comes to the SIRT team or computer emergency and response team, that how do they define that their handling of the evidences should go ahead. So towards the end, so my major focus was to enlighten or make sure that you understand the concept of proxy. There are different application domains. It need not be that you can relate a proxy in the security only to the forensic or investigation domain. That might be very, you can say, a specific path, but a proxy signature, as I mentioned, e-governance has got a lot of implementations related to proxy. Similarly, the other domains are there. Finance is one of the other domain wherein the proxy signatures are being majorly used. There are many other domains like cyber physical systems are also there, which are majorly also trying to make use of the proxy systems. So this is from my side. Any questions related to this specific or any other topic you would like to ask? Any other questions? I'm ready to. So I'll be more than happy to sleepy, but this is the field which requires thorough, I'm not questioning on that, but it requires thorough study on it previously and a special interest. It's not like it's a special interest category kind of thing. Thank you for inviting me here and giving me opportunity to have talk with you. Though I expect that the talk to be two-way, both the way, but it has eventually been reduced to one-way communication. But anyway, thank you.
I would like to thank Dr. Bennare ma'am for giving information on use of proxy signature for delegation of the authority and its application in forensic investigation. Ma'am has explained the generation of proxy